There are many risks with cybersecurity, but quantum computing poses a significant one. From medical research to artificial intelligence and everything in between, quantum computing is game-changing. But how will it change our traditional cybersecurity? You're watching YouTube channel. Let's get techie. In today's video, we will talk about the truth about how quantum computing will change traditional cybersecurity. The field of quantum computing is still in its early stages, but the technology will be impacting many industries much sooner than most people realize. In fact, Google has developed a quantum computer that can solve problems previously considered impossible due to their complexity, and they do it almost instantaneously. So make sure to watch the video until the end. And if you are new to the channel, subscribe to the channel and hit the bell icon, so you will not miss any future videos we upload. Before going forwards, let's first talk a little bit about quantum computing. A quantum computer, or quantum annealer, is a type of computer that operates on quantum theory. Quantum computers are able to process much larger data sets and perform much more complex computations than even the world's most powerful supercomputers relying on classical computing. They can solve problems previously considered impossible due to their complexity, and they do it almost instantaneously. Google developed its first quantum computer in 2019, with D-Wave delivering a commercially available machine a year later. Your data is going to change. It's inevitable. In a world where the future is uncertain and risks seem to be on the rise, it's hard to keep up with all the potential challenges. But what if there was an easy way to mitigate these challenges ahead of time? Quantum computing, emerging technology, has already been proven capable of solving complex problems that no other technology can tackle right now. Quantum computing unlocks a whole new world of possibilities, but it's not all good news. Let's see what it means for cybersecurity and data protection in the near future. What will the future look like? We may soon find out. Quantum computing is about to revolutionize our world. Quantum computers are able to break encryption, pattern analysis, or by analyzing massive data. Through a mix of hardware and software, quantum computers work with qubits that make it possible to store and compute exponentially more data than traditional computers. With this technology, experts estimate we will be able to accelerate solutions to complex problems. Public key encryption is the most common form of internet encryption that we use today. It relies on the keys used for encryption to be public knowledge, but the decryption key to be private. The underlying PKI is built into every web browser in use today to secure traffic across the public internet. However, with the advent of quantum computing, this technology could easily be hacked by a new type of algorithm that can break through these complex security measures. This is a time of unprecedented vulnerability. The days of quantum computing have come, and with them, we are seeing the end of PKI. This is a time of unprecedented vulnerability. Cybercriminals will be able to decrypt sensitive information without ever having access to the decryption key. They'll be able to break public key encryption almost instantly. New methods to encrypt information are developed, including post-quantum cryptography, which is dedicated to developing new approaches to encryption that could replace today's methods and remain secure in the quantum computing age. With a quantum computer, those problems would be solved in a matter of seconds. This includes solving the algorithms behind encryption keys that protect our data and the internet's infrastructure. Much of today's encryption is based on mathematical formulas that would take today's computers an impractically long time to decode. To break through the age-old limits of classical computer systems, scientists have been working on quantum computers. Inspired by Shor's algorithm, their goal is to develop quantum computers that can factor increasingly larger numbers. Today, RSA encryption, widely used to send sensitive data over the internet, is based on 2048-bit numbers. Experts estimate that a quantum computer would need to be about 70 million qubits if it were going to break this type of code. Considering the largest quantum computer available now is IBM's 53-qubit quantum computer, we might not have an opportunity anytime soon to see RSA cryptography broken. With every new day, quantum computing technology moves just closer and closer to becoming a reality. This isn't to say it is possible now. We are still many steps away from perfecting this type of technology. But each day, quantum computing advances another step. For example, last week Google and the TECHY Royal Institute of Technology in Sweden reported finding a more efficient way for quantum computers to perform the code-breaking calculations which would reduce the resource requirements by orders of magnitude. A closer to reality day is just around the corner. The importance of this is at least twofold. First, it means the security industry now has the technology to develop a range of quantum computing hardware that can accommodate and test a wide range of quantum algorithms. Second, the success of quantum computing hardware has the potential to significantly impact the speed of emerging technologies such as artificial intelligence. It's important to note that perishable sensitive data is not the main concern when it comes to the quantum encryption threat. The greater risk is the vulnerability of information that needs to maintain its secrecy for a long time, such as national security level data, banking data, and Privacy Act data. These are the secrets that need to be protected with quantum-proof encryption now, particularly because there are those out there actively trying to steal these things before they can purchase or build a powerful enough quantum computer capable of breaking through today's encryptions. In recent years, researchers have been working diligently to create quantum-safe encryption. According to an article published by the American scientist, the U.S. National Institute of Standards and Technology has already evaluated 69 different potential new methods for what they call post-quantum cryptography, or PQC. To protect against an attacker breaking the encryption, the American inventor has created a concept called the Quantum Message Authentication Code. This system uses 2 qubits, quantum bits, and works by encoding the secret message in the physical vibrations of 2 entangled photons. The paper reveals that if an attacker measures one of the photons with a device that is not part of the quantum device, they cannot possibly measure the second photon. These qubits are being manufactured in Germany by Fraunhofer and are the basis for his quantum key distribution system, or QKD for short. It has been argued that there are many unanswered questions surrounding quantum computing. Yet even if this is true, there seems to be one thing agreed upon by most experts. The advances made in quantum computing will pose a serious threat to our current cryptography systems. There needs to be some type of system put into place that mitigates this very risk before an attack can happen. Specifically something which minimizes cyber attacks coming from parties with access to good computers, quantum or not. It doesn't really matter what type of information people need to keep private, but it does matter whether they take measures against any possible breaches, no matter what field they come from, because nothing stays hack-proof forever. Cybersecurity experts know this too well and work hard at finding new solutions for these cases without putting all hope on just one area, which would leave them exposed if the technology fails under pressure or becomes obsolete due to newer technologies being developed. Last but not least, the era of the quantum revolution has arrived. In spite of the fact that it may take another decade for large-scale, error-tolerant quantum computers to have a dramatic influence, near-term quantum computing will nevertheless have a significant positive impact. There has been a significant amount of effort directed toward finding solutions to the fundamental issues around scaling the qubit count, error correction, and algorithm design. Quantum computing has the potential to offer a far higher degree of communication security and privacy. And while this may render certain currently used encryption algorithms obsolete, it also has the potential to make some of these protocols obsolete altogether. In order to be prepared for the quantum revolution that will occur in the future, businesses need to engage in substantial preparations, now while also engaging in strategic planning on the potential hazards and rewards posed by quantum computing and technology in the later period. That's all for today's video, guys. What do you think of today's video? Tell us your views in the comment section. Thank you very much for taking the time to watch this video. See you in the next video. Until then, cheers.